In this chapter, we're introducing the concept of inheritance. Inheritance plays an important role in object-oriented programming because it allows us to build classes and then reuse that class in the definition of another class. A lot of times you'll hear of inheritance used with the term specialization. For example, let's say we have a class called motor vehicle, and then we decide we want a specialization of that, a car or automobile class. Or then later on we might want a truck class, which is again a specialization of motor vehicle. Being able to use inheritance allows us to reuse code quite a bit because a specialization of a original class called the base class can use the code from the base class over and over again. So things that are common to all the classes we can define once and not have to define them again in a specialization, which is also called a derived class. We'll spend quite a bit of time in this chapter talking about all these things, so the best thing to do now is to get started by having a quick review of objects and classes by building a base class for the next few lessons. And this class is going to be an employee class. So to begin the class definition, we start outside event main. We start the class with its class name employee. Then we drop down, set up the private data members first. Here we're going to have two, a name and a pay rate, or pay. Then for our public section, we'll need, first of all, a default constructor, and then a more complete constructor. Let's scroll this down just a little bit. And so name is equal to int name and pay is equal to pay rate. We're going to ignore any issues of data validation for now to try to keep our code as simple as possible and so that we can concentrate on inheritance and not on other issues. Let's also go ahead and write some getters and setters for each of these members, name and pay, just to kind of get back in practice. So we'll start out with a getter. We'll get the name. Then we'll write a setter. Then we'll write a getter for pay. And then a setter for pay. Finally, let's write a toString function. But to do that, we're going to have to introduce a new idea. First, let me show you what I would want the toString function to do. ToString should be used to return the current state of the object. So we want it to return the name plus the pay rate. It is pay. And we can do that in several different ways. I'm just going to do the name followed by a colon followed by the pay rate. Let's go ahead and finish the definition and finish the class definition also, although we're coming right back. Oh, I see. We have a little problem here. Again, our policy is to not hide the errors, but to show you how to fix them. So we had a dangling closing curly brace. Now we're going to close the class definition. Now let's come back to toString. This line of code will not compile because we cannot concatenate a string to a double. So what we need to do instead is introduce a new library called the string stream. String stream. First, let me put the library in. STREAM or SStream. And then let me demonstrate how to use it. We're going to talk about string streams a lot more later in the course. In fact, we'll have a whole chapter on Stream.io and we'll talk more about it. But we need that concept right here. So what we're going to do is we're going to create a string stream object. Well, let's call it STM. And you can think of it like the console out object, or cout. We're going to flow double and string data to it, name and pay, just like we stream it to the cout object. And then we can turn that into a string and then return it as a return value of our function. So it works just like this. So, and then we just say return stm string. That turns the stream into a string object, and we're complete. So let's test our class with a couple of employee objects just to make sure that it works. We won't cover all of it. So we'll create Jane Smith, give her a salary. We'll create a second employee, Bill Brown, give him a salary, and we'll write out their values using toString. Like so. And that should be all we need. Take a look. Let's go up and build and run the program. Put it into your screen. And there you see that Jane Smith has a pay of $35,000 and Bill Brown has a pay of $32,000. So this class employee will now become the base class for a set of specializations or derived classes that we can use to define the different types of employees in a company. For example, we can have hourly employees and managers will be the two that we look at. And we'll get started with that, and we'll begin looking at how to create those derived classes in the next lesson.